Have you ever noticed that time seems to fly when you're having fun and crawl when you're bored? That's not just a feeling, it's a clue that time is far stranger than we think. Today, we're going to ask a question that has haunted philosophers, physicists, and poets for millennia. What is time, really? Most of us think of time the way a clock looks, a steady, ticking line moving forward. Past on the left, future on the right, the present, right here, right now. But that picture is almost certainly wrong, or at least radically incomplete. Let's start with the basics. Time is a dimension, just like length, width, and height. Together, these four dimensions make up what physicists call space-time. You don't just exist somewhere, you exist somewhere. Every event in the universe has an address, three spatial coordinates and one in time. This idea came from Albert Einstein, who published his special theory of relativity in 1905. And what he discovered was shocking. Time is not the same for everyone. Time passes differently depending on how fast you're moving. The faster you travel through space, the slower you travel through time. This isn't science fiction, it's been measured with atomic clocks on airplanes. Clocks on fast-moving planes tick ever so slightly slower than clocks on the ground. The difference is tiny in everyday life, but absolutely real. GPS satellites have to correct for this effect just to give you accurate directions. Then Einstein went further with his general theory of relativity in 1915. He showed that gravity also warps time. The stronger the gravitational field, the slower time flows. Time passes faster for astronauts in orbit than for us on Earth's surface. Near a black hole, time slows so dramatically it almost stops. If you could hover just outside a black hole and then return, thousands of years might have passed on Earth. Time dilation isn't metaphorical, it is the fabric of the universe bending. Space and time are not a backdrop. They are physical things that can stretch and warp. But here's where it gets really weird. Physics, as we currently understand it, has no preferred direction for time. The equations of physics work equally well forwards and backwards. A video of two billiard balls colliding looks physically plausible whether you play it forward or in reverse. So why does time seem to only move in one direction? Forward? Why can you remember yesterday but not tomorrow? This is called the arrow of time, and it's one of the deepest unsolved problems in physics. The leading answer involves entropy, the tendency of systems to become more disordered over time. Think of it this way. You can scramble an egg, but you can't unscramble it. A cup can fall and shatter, but shards never spontaneously leap back into a cup. These processes are irreversible, not because physics forbids the reverse, but because it's astronomically unlikely. Time's arrow, in this view, is a statistical phenomenon, not a fundamental law. But this raises an even deeper question. Did time have a beginning? According to our best cosmological models, the answer is yes. Time itself began with the Big Bang, approximately 13.8 billion years ago. Before that moment, there was no before. This is hard to wrap your mind around, and that's okay. Even physicists find it disorienting. The question, what happened before the Big Bang, may be as meaningless as asking what's north of the North Pole. There's simply no such place, or in this case, no such time. Now let's zoom inward, into quantum mechanics, the physics of the very small. At the quantum level, time gets even stranger. Some physicists believe time may be fundamentally discrete, broken into tiny, indivisible chunks called Planck time. One Planck time is approximately 5.4 times 10 to the minus 44 seconds, far beyond anything we can measure. And there are even more radical proposals. Some physicists, like Julian Barbour, argue that time doesn't actually exist at all. What we perceive as time, he says, is really just a sequence of nows, individual snapshots of the universe. The flow of time, in this view, is an illusion created by our memories and consciousness. Other theories suggest time is an emergent property like temperature. Temperature isn't a fundamental thing. It arises from the average motion of many particles. Maybe time, too, arises from something deeper we haven't yet discovered. Some quantum gravity researchers think time emerges from quantum entanglement itself. Then there's the question of how we experience time. Neuroscience tells us the brain actively constructs our sense of time. It doesn't passively record moments. It predicts, reconstructs, and occasionally gets it completely wrong. Under stress or in danger, the brain processes more information per second, making time seem to slow down. When you're deeply engaged in something you love, your brain suppresses its time tracking circuits. That's why hours can vanish in what feels like minutes. Boredom does the opposite. It heightens your attention to the passage of time, making it feel agonizingly slow. We don't experience time, we construct it. There's also the puzzle of the specious present, the psychological window we experience as now. It lasts roughly 2 to 3 seconds. Anything within that window feels simultaneous, even if it isn't. The now you think you're living in is actually a brief, edited highlight reel assembled by your brain. So where does all this leave us? Time is real, but not in the simple way we imagine. It's relative. It warps with speed and gravity. It has a direction, but only statistically, not fundamentally. It had a beginning, but there may have been no before. And our experience of it is a construction, shaped by memory, attention, and consciousness. We are beings made of time. Every thought you've had, every memory you treasure, every plan you've made, all of it is written in time. And yet, time itself remains one of the universe's deepest mysteries. The more closely you look at it, the more it seems to slip away, like the present moment itself. Perhaps that's the most honest answer we can give. Time is the medium in which existence happens. It is the stage, and we are the play. And figuring out what the stage is made of, that's the work of generations still to come. If you enjoyed this video, consider subscribing. We explore questions like this every week. And if you have a question you'd like us to unpack, drop it in the comments below. Until next time, which, as you now know, is a very complicated thing.